Hello guys, I am SWAPNIL PAL and I am today going to explain you about class 9th first chapter of science, that is matter and our surroundings. So let's start. We all know that everything in this earth is made up of matter and matter is made up of atoms. So what are the physical nature of matter? I can say that first, matter is made up of many tiny particles. Second, those tiny particles of matter continuously moving and the third one is that the matter is made up of tiny particles. So those tiny particles are atoms or molecules. Let's understand what's diffusion is. Diffusion is the intermixing of particles of different kind of matter on their own. These three words are very important, as if we will not write in an exam, our teacher will deduct half marks there if we will not write this. And diffusion is also known as movement of particles from their high concentration to their lower concentration. Next topic comes here is Brownian motion. What does Brownian motion means? Brownian motion is the zigzag movement of particles in a very irregular manner. Like we can see an example, there's a window in a room and from window the light enters. So when the light enters, the path of light, we can see many particles move like this, and in all direction. So it is a zigzag movement, like this is zigzag, like this. We can also say we take a water in a glass. Then we put a pollen grain in it, and the pollen grain will move like this in a very irregular way. So this is known as Brownian motion. So the next topic comes is the characteristics, particles of matter. Characteristics of particles of matter. What are the characteristics? First, the character that the particles of matter are very very small. Let's see an evidence. We will take a beaker in which water will be filled. We will dissolve some sugar particles in it, or we will dissolve some sugar in it and stir it with a glass rod and leave it for some times. Now when we will see afterwards, the water level doesn't change. But why so? Because the sugar particles get divided into more small number of particles, and the space present between them, the particles, and settle in this. So this we can conclude that the particle of matter are very small, as they are dividing up into small number of particles. And so this shows that the particles of matter have space between them, because the sugar particles go and set up in the space present between particles of water. So here we can conclude that the particles of matter, the space between them. We can see another examples of that the particles of matter are very small. How? We'll take a beaker, we will take some water in it, we will dissolve 2-3 crystals of potassium permanganate, that is KMnO4. KMnO4. Now we will take a test tube take another beaker with water, take a test tube, take another beaker, water filled, and so on. See, this will be very dark purple color. We will take out 10 ml from this and put it in this. So the particles of the potassium permanganate will split up into more number of particles as to color this complete solvent. Now we will take again 10 ml from this and put it into this. So the particles in this which have subdivided into more number of particles now will be also again be divided into more small number of particles as to color this whole. So we can conclude that the particles of matter are continuously dividing up in this. So here the color was dark, here the color was somewhat light, here the color was light, and later on the time will come then that we will see a purified water, a clean purified water, not a purified water but a clean water. Second property is that the particles of matter have space between them, that we have concluded here only, that the sugar particles divide into small number of particles and go and settle down in the voids. These are the spaces that are present between the particles of matter are known as voids. So the sugar particles go and settle down in voids, and this concluded that the particles of matter have space between them. Another property is that the particles of matter attract each other. The particles of matter attract each other by two forces. One is cohesive force, another one is adhesive force. What's cohesive force? Cohesive force is the force of attraction. Is the force of attraction between the particles of same type of matter or same substance. What's adhesive force? Is the force of attraction between the particles of different kind of substances. Now next topic comes, what's rigidity means. Rigidity means unblending or unflexible, mainly or basically solids are rigid. Second one is fluid. Fluid means what the fluid means is the fluids are the substances which have tendency to float. Basically they are fluids are gases and liquids. The third comes as viscosity. What viscosity means is resistance to flow. Now comes the classification of matter. Classification of matter. Here comes 8 properties. The first is interparticle space, interparticle force, diffusion, compression, kinetic energy, then nature, and shape and volume. The last one is density. Let's classify them. Solid, liquid, the last one gas. Interparticle space is negligible. Interparticle space in liquids is more than solid. Gas has high interparticle space. Interparticle force is very strong. Interparticle force is less than solid. It's very weak. It's diffusion. Diffusion, intermixing of particles of different kind of matter by their own. Fusion is negligible, same, because particles are closely attached. Diffusion in liquids is more than solid. Diffusion is very fast. Compressibility again negligible. They are more compressible than solids. They are highly compressible. They are highly compressible. Kinetic energy is least. Kinetic energy of liquid is more than solid. Very high kinetic energy. Nature, it's rigid, it is fluid, and gas is also fluid. Shape and volume, it has definite shape and volume. It has definite shape but indefinite volume. It has indefinite shape and volume both. But density is a mass per volume. Density is in Hindi is also known as ghanapan. So density is very high density. Its density is lower than solid. Negligible. No, we can't say negligible. Low density. This classification. Now here comes the interconversion of conversion of states of matter that are first boiling. Now let's start with a tabular form. Not a tabular form, mainly basically like something like this: solid, liquid, gas. Solid can be converted into liquid by melting. Liquid can be converted into solid by freezing or solidification. Liquid can be converted into gas by vaporization. Gas can be converted into liquid by condensation. Solid can be converted into gas, and gas can be converted into solids by the same process known as sublimation. So new topics come here. So what is melting? The interconversion of solid into liquid at 1 atm pressure by absorbing heat energy. What's freezing? Freezing is the interconversion of liquid into solid by giving out heat energy at 1 atm pressure. What's melting point? Melting point is the constant temperature at which a solid changes into liquid by absorbing heat at 1 atm pressure. And what's freezing point is the constant temperature at which a liquid changes into solid state by giving out heat energy at 1 atm pressure. Now here comes what's latent heat of fusion means. Latent heat of fusion means the amount of heat required to convert 1 kg of solid into liquid at its melting point and at 1 atm pressure. So another comes is boiling or vaporization. So boiling is interconversion of say of or we can say that the process due to which a liquid changes into gas by absorbing heat energy. And what's condensation is also known as liquefaction, like in which the gas is converted into liquid by giving out heat energy. So here comes the another term. Wait, we are left with one topic. What's boiling point? Boiling point is the constant temperature at which the liquid is converted into gas by absorbing heat energy at 1 atm temperature or pressure. And what's condensation point or liquefaction point? Is the conversion of gas into liquid at 1 atm pressure and by giving out heat energy. So another term comes here is latent heat of vaporization. Latent heat of vaporization is the amount of heat required to convert 1 kg of liquid 1 kg of liquid into gas at its boiling point at 1 atm temperature or pressure. What is the latent heat of fusion of ice? It's 3.34 into 10 to the power 5 joules per kilograms. And what is the latent heat of vaporization of water? Is 2.25 into 10 to the power 5 joules per kilogram. Now let's understand why is ice at 273 Kelvin more effective in cooling than water at the same temperature. So the answer is very simple, that ice, that is a solid water, has extra energy in the form of latent heat of fusion as compared to water. So due to the absorption of energy, the temperature of the surrounding gets lowered or cooling is caused. Since water is already present in a liquid, so it does not absorb energy from the surroundings. Thus ice at 273 Kelvin causes more cooling effect than water at the same temperature. Another question comes that what produces more severe burns, boiling water or a steam? Of course, when water, that is a liquid form, at 373 Kelvin or 100 degrees Celsius is converted into steam at 100 degrees Celsius. When water at 373 degree Kelvin is converted into steam at 373 Kelvin, it absorbs equal energy to latent heat of vaporization from surroundings. Thus, steam, that is vapors form of water at 373 Kelvin, that is 100 degrees Celsius, have more energy than water at same temperature. Hence, steam produces more severe burns than boiling water. Here comes the next topic, evaporation. What evaporation means is the phenomena of change of liquid into, not gas, into vapors at any temperature below its boiling point. What are the factors affecting evaporation? Factor there are four factors that affects evaporation, rate of evaporation. That first is the surface area. The surface area directly proportional to rate of evaporation. As the surface area increases, the rate of evaporation increases. As the surface area decreases, the rate of evaporation decreases. Second one is the humidity. Humidity is not directly proportional, it's inversely proportional to rate of evaporation. As what's humidity? Humidity is the amount of water vapor present in air. When the humidity is less, the rate of evaporation is more, and when the humidity is more, the rate of evaporation is less. Third one is the wind speed. So wind speed is directly proportional to rate of evaporation. As the wind speed increases, the rate of evaporation increases, and when the wind speed decreases, the rate of evaporation decreases. The fourth one, that the nature of substance. Is directly proportional to rate of evaporation. That is, surface with low boiling point will evaporate faster, and the with high boiling point will evaporate slower. Here the major question comes that what's the difference between evaporation and boiling? See, evaporation is a not bulk. Evaporation is a surface phenomena. Boiling is a bulk phenomena. Evaporation is a silent process. Boiling is a violent process. It occurs at all temperature below boiling point. It occurs only at boiling point. The rate of evaporation is directly proportional to surface area, wind speed, nature of the substance, and the rate of evaporation is inversely proportional to humidity. The rate of boiling point does not depend on all these things. This is the major difference between boiling and evaporation. That is surface phenomena, bulk phenomena, silent process, violent process. That is slow process, that is fast process. No. Yeah, that is a slow process. A silent process, that is a violent process, that is a very fast process. This occurs at all time below BP, occurs at only at BP. The rate of evaporation directly proportional to surface area, wind speed, and nature, inversely proportional to humidity. The rate of evaporation, boiling point. Hence, one of the odds came here that why we wear cotton clothes in summer. During summer, we wear cotton clothes because of the mechanism of our body which keeps us cool. During evaporation, the particles of the substance of liquids gain energy from the surroundings of the body surface. Heat is equal to the latent heat of evaporation is absorbed from the body, leaving body cool. Cotton is a being good absorber of water, helps in absorbing the sweat. Second, the pouring of acetone on our palm. We pour some acetone on our palm, so the acetone will take up latent heat of vaporization from our palm and leaving leaving the palm cool. So hence, when it vaporizes, it leaves a palm cool. So the mechanism of that, we wear cotton clothes as in summer we sweat. So cotton clothes, being a good absorber of sweat, so they absorb the sweat and they absorb the sweat. So the sweat acquires some amount of latent heat of vaporization from the surrounding and leaves the cooling effect on our body, and hence we wear cotton clothes in summer. And last one is that why we can see the water droplets on the outer surface of the glass containing cold water, because the water vapors present in air comes contact with the glass of cold water and loses energy. Hence, the water vapor converts into liquid and sticks on the glass. So, thank you. Like this video and please subscribe it. Thank you.